Hello, ladies and gentlemen. We are almost done with chapter 6. We're going to do 6.5 and 6.6 today. So I'm just going to record each video separately in case you want to watch them at separate times. Alright, the objectives for today are to talk about the parent function for the square root and the cube. Then we're going to discuss domain and range. We haven't done that yet. And then we're going to talk about how you report the domain and range. Alright. The domain of a function are all x values, U-E-S, sorry, couldn't write, that make a function true. Okay, we report the domain left to right, just like we do most of our math. We're going to report it left to right because we read left to right, and we're going to report it in interval notation, and we haven't done interval notation in a while, so we'll go back and review that. The range then is all of the y values that make a function true. Later in the year this will become a little bit more entertaining. We report our range from the bottom up. Okay? And again, we're going to do it in interval notation. Alright, so let's just do a couple of examples to get us started because I think that makes more sense. Alright, so here's my first example, and I'm going to have just a little graph of a parabola, and my parabola is going to go up, and it's going to go through the origin. I guess you can't see it. There is nothing that creates any breaks in the graph. I don't have any holes. I don't have any asymptotes. We'll talk about those later in the year. So my domain is going to be all real numbers, and I write that as a negative infinity to a positive infinity. So that would be my domain. My range talks about the y values in this graph. Well, my y values start at 0 and go up, okay? There's nothing below the x-axis, so my range would be all of the y values greater than or equal to 0. Remember, I said we start at the bottom and go up. The 0 is included and the infinity is not, okay? And that would be my range. Alrighty. So now let's take this graph of our handy-dandy little parabola and let's shift it. Let's translate it. Okay? So I'm going to scoot it over here. I'm going to tell you that its vertex is going to be a 3, -2, and its equation is going to be y is equal to x minus 3 quantity squared minus 2. Okay, so again, sorry, I guess you still can't see, there's nothing that makes this graph undefined. There are no breaks in the graph. Therefore, my domain is going to be all real numbers. And I write all real numbers saying that it goes from negative infinity to positive infinity without any breaks. Okay, my range, this particular graph, the y values start at a -2 and then they go up. So my range is going to start at a -2 and it's going to go up to positive infinity. So now let's do a different kind of function. Let's do y is equal to the square root of x. And notice I didn't do plus or minus x. I just did the square root of x. Well, if I graph this, and we'll talk about values and how to generate those later, it starts at 0 because the square root of 0 is 0, and the values go to the right. There aren't any values over here on the left because I can't take the square root of a negative number and show it graphically. I can do it algebraically, but I can't show the graph of a negative number on my the graph of a negative root. So on this one, my domain is a wee bit different. It starts at 0 and it goes to positive infinity. Okay? Alrighty. And then my range on this one is going to start at 0, oops, the 0 is included, and also go to positive infinity. So on this one, the domain and the range are the same. All right. So if I show you another graph, let's say I have the graph of y is equal to, hang on just a sec, I was correcting and made a mistake in my notes, the cube root of x. The graph of this looks like this kind of. It's kind of a cool looking graph, okay? I guess it doesn't go back down. So there's the graph of y is equal to the cube root of x. So without talking about what the values are or anything else, I can talk about my domain and range. My domain has nothing that makes it undefined, so it's all real numbers. My range also goes from a negative infinity, remember this is the bottom, and it goes to the top, it's a positive infinity. Alrighty, okay? I think I won't show you any more complicated graphs and we'll just leave it at that. So now what I'm going to talk about are what's called parent functions. And I think we've talked about some of these before, but this just means this is a basic function. And I think we talked about this when we talked about a parabola. But for my first parent function, it's called the square root function, and I'm going to do the square root of x. So to graph this, I could generate a table of values, okay? But I'm actually not going to do that. Okay, so I'm just going to sketch my graph. It starts at 0, 0. Remember we've talked about it can't go to the left, so it's undefined over here on the left. Okay, I could do a couple of points. If I let x equal 1, the square root of 1 is also 1, so it's going to go through that point. Let's say I did 2, 3, 4, and I let x equal 4. The square root of 4 is 2. So that would be the 2, and the graph of the square root function looks like that. Okay? And notice again that I'm only doing the positive side of the curve. If I want to do both sides of the curve, because it's an even function, so if I did plus or minus radical x, and I graph it, okay, and I'm not going to put points on this one, here's the top half of the curve, that's the positive square root, and then if I do the bottom half of the curve, here's the bottom half of the curve. So this is the plus or minus square root of x. This is just the positive square root of x. All right? Okay, so now I'm going to graph y is equal to x cubed. And we've talked about this before when we talked about the end behavior of some of our polynomials. And the graph of that function looks like this. Y is equal to x cubed is also a parent function. It's called the cubic function. Well, if I want to graph y is equal to the cube root of x, remember that this graph is a reflection because it's the inverse, and it's going to actually look like this, okay? And so that would be my graph of the cube root of x. All right, so now I'm going to do a couple of examples for you, okay, except you can't see them. So it's helpful if you can see the examples that I'm going to do, okay? So my first example, I want to graph y is equal to 1/2 the square root of x. I want to state the domain and range. Okay, and then I'm going to talk about what's actually happening. We're not going to describe it yet, but I'm just going to walk you through it. Remember, if the value is in front of the function, that means that it is a vertical change. So the 1/2 is actually a vertical shrink. Okay, so I'm going to illustrate this with my grapher, okay, so you can see the effect. So if I go into my grapher and I delete all of the stuff that I had, I'm going to enter the original function, so the square root of x, and then I'm going to enter my 1 divided by 2, and then the square root of x, and I'm going to graph both, okay? So as I hit graph, that's the square root of x, and then there's 1/2 the square root of x. So notice that it is a vertical shrink, and it compressed the graph. So that's kind of cool. So I'm going to leave that there. I'm going to talk about my domain. My domain starts at 0 and goes to positive infinity. My range also starts at 0 and also goes to positive infinity. Alrighty. So now let me show you another example. Okay. And again, we're going to have the same directions. So we're going to graph, and then we're going to state the domain and the range. Okay? This one is going to be y is equal to 4 times the cube root of x. Okay? So again, the 4 that's the value out front is a vertical stretch factor. So the 4 is a vertical stretch, which means that the graph is going to get taller. And I'm going to graph both equations so you can see what they look like. So I'm going to graph x raised to the 1/3. Okay, that's my parent equation. And then I'm going to graph here, I'll scoot it over here. Then I'm going to graph my second one. It's going to be 4 times x raised to the 1 divided by 3. And then I'm going to hit graph. So this is the cube root, okay? And this one is the one that has the vertical stretch factor of 4. Noticing that it gets taller and bigger, so that is what happens when I have a vertical stretch of 4. I'm going to scoot that off to the side. The domain, there's nothing that makes this graph undefined or creates any holes, so it's going to be a negative infinity to a positive infinity, and my range is going to be the same. Alrighty, so now let's talk about our parent functions a little bit more, and let's talk about translations. And we've talked about these many times before, but we'll use them in reference to the two new parent functions. So the first one is my square root, and if I have y is equal to a times x minus h, and then outside the radical plus k. And then for my cubic, if I have an a, and then I have the cube root of x minus h plus k. So remember that the a is the vertical stretch or shrink for both equations. If a is greater than 1, then it is a stretch. And if a is less than 1, like a fraction, then that means that it is a shrink. If a is negative, okay, if a is negative, then it reflects across the x-axis. Okay, and we've done all of this before. Alrighty. My h is a horizontal translation. And remember, anything that's horizontal is going to be the opposite. Okay? So in my equation, if I have a negative h, then it's going to go right h. And if I had a positive h in my equation, that would be left h. Okay? Because two negatives makes a positive. Alright, and then my k is my vertical translation. Vertical things are nice because they're always exactly what they say. So if k is positive, then the graph goes up. And if k is negative, then my graph goes down. Alright, so those are all the things that we've talked about with translations before. Alrighty. So we just have two more examples for you, and then we'll get on to your problems. Alright, so the next example, I'm going to give you y is equal to 3 to the cube root of x plus 4 minus 1. I want you to describe the transformations. The calculator's in the way. And I want you to talk about the domain and the range. And we're going to use our grapher to help us with that one. Alrighty. So if I start on the left and I go to the right, because we read left to right, the 3 is a vertical stretch, which makes the graph taller, bigger. The 4 means that it moves left 4. Remember, it's always the opposite. And the negative 1 means that it moves down 1. So now what I'm going to do is bring my grapher in. Okay, I'm going to clear what I have. Alright, I'm going to push it up here so you can see it. I'm going to enter my equation. So I have 3 times x plus 4 raised to the 1/3, and then outside of that I'm going to do my -1. Okay, so notice how I entered it. The 3, the x plus 4 has to be in parentheses, raise that to the 1/3, which also has to be in parentheses, and then subtract 1, and then I'm going to hit graph. So notice that the graph is looking a little bit taller and bigger. It's been shifted 4 units to the left. Okay? There's nothing that makes this graph undefined even though it has moved. So I would say for the domain that it's going to be all reals, and my range is also going to be all reals. So that was very polite. All right, my next equation, or sorry, my next example, same direction. So I want to describe the transformations, and then I want to talk about its domain and range. So it's going to be y is equal to a -2, x minus 3, outside the radical is plus 2. So again, I'm going to start on the left. The negative means that it is a reflection across the x-axis. You always have to tell me which axis because we could have a reflection across the y. Okay, the 3 moves it right 3, remember, because it does exactly opposite of what the sign says when it's inside the function. And 2 is outside the function, so it's going to move up 2. All right, now the square root is interesting. Remember that you can't take the square root of a negative number. So this graph is actually going to start at a +3, and then it's going to change. So let me bring my equation in, and I'll enter our equation. There's the -2, and I'm going to do the square root of x minus 3. You need to close the parentheses, outside that, and graph. Okay, and I'm going to move my cursor. Remember, we've talked about this kind of over here, and I'm going to do a zoom to enter so that we can see it a little bit better. Okay, so notice that my graph started at the 3 and then it goes down. So I could actually find the coordinates of that point. It is 3, 2. Okay, so I could find the coordinates by substituting. Remember, I could substitute in the x is 3. So if I let x equal 3, and I'm doing that because it makes this be 0 underneath the radical, anything to the left of 3 is going to be undefined. When I substitute that into the equation, I get a -2, 3 minus 3 plus 2. So I get a -2 times the square root of 0 plus 2. Well, this is 0, so my point is my coordinates are going to be 3, 2. And that's going to be the coordinates of this point right here. Okay? So I'm actually going to just sketch a little piece of this so I can show it to you. So this piece right here is 3, 2. So now I can talk about my domain and range. My domain is undefined to the left of 3, so my domain is going to start at 3 and go forever to the right. My range also actually starts at 3. Oops, sorry, my bad. We go from the bottom up. It's going to go from a -infinity to 3, and it stops at the 3. Alrighty. Okay. Oh, and I said range. That should be a 2. Sorry. Alrighty. So my range, my y values, are coming up from the bottom, and they're stopping at y is equal to 2. Alrighty. So that's the end of the first video. If you need your grapher to help you see some of your graphs, you're more than welcome to use it. Here are your problems. Okay, so as promised, the first video is not too terribly long. I want you to graph the function. I want you to label the important points. Okay. And then state the domain and range. And then I want you lastly to describe sorry, the transformations. All right, so your first equation is y is equal to 1/4 to the cube root of x And your second equation is y is equal to a negative 4/5 times the square root of x. The third one, y is equal to a negative 4th to the square root of x minus 5 plus 1. And my fourth equation is y is equal to 2 times the cube root of x plus 5 plus 6. Alrighty, there are your problems. When you're done with those, you can start the next video. Good luck!